Hi everyone. Today we're going to take a look at neutralization reactions, but we're going to look at it with calculations involved. So this is basically, you will have seen some of this in your grade 11 course. So it's kind of a review from the grade 11, just using neutralization reactions. Okay, here. So we can use neutralization reactions to determine the concentration or volume of an acid or base. So basically we're following the mole ratios. We're following stoichiometric relationships, but we're using, instead of grams, we're using volumes because we're looking at the aqueous solutions. So we're going to use our solutions information. So we're going to just jump into an example here so you can copy this down. In the reaction of 35.0 mils of drain cleaner containing sodium hydroxide, 50.08 mils of 0.409 moles per liter or molar HCl must be added to neutralize the base. What is the concentration of the base in the cleaner? So when you're approached with a problem like this, your very first step is always going to be to write the equation. And that's just a standard rule of thumb for any chemistry problem here. So we're going to go NaOH. So you've got NaOH, which is sort of the active ingredient here in the drain cleaner. I'm going to add to that HCl. And then that's going to become, when this is a double displacement reaction, and it's also a neutralization equation. So you know that one of your products here is going to be water, and the other one is the salt. And in this case, the salt is literally NaCl. Okay, so we have our equation here. This is going to be, let's put our states in here. That's going to be a liquid, sorry, you can't really see that well. That's an L there. This will be aqueous. And these two are both aqueous. Now, I like to organize my data, and so I like to put what I know underneath the appropriate compound here. So I know that I've got 35 milliliters of the drain cleaner, but that I'm going to worry about that later. But I've got 50.08 milliliters of the hydrochloric acid, and I know the molarity of that is 4.409 molar. Okay, so that's going to be important information here. And again, here I know that I've got 35.0 milliliters of the NaOH. Now, the question is asking me, what is the concentration of the base in the cleaner? So M question mark is what I'm looking for here. Now, in order to find the concentration, I need two things. So you're going to reuse your equation here for molarity, so moles per liter. Now, do I have the volume? Yes, I've got the volume. Do I have the moles? No, I don't have the moles. So that's what I need to find before I can find the molarity of the sodium hydroxide. But by looking at this equation, I can look at my hydrochloric acid, and here I've got a volume and I've got a molarity. So can I find moles from those two pieces of information? Yes, I can. So I can do that, and then I can use my mole ratio from the balanced equation here to find the moles of the sodium hydroxide. So let's go ahead and do this here. So if I rearrange this equation here for moles, I'm going to get moles, and I'm just going to write here NaOH so I don't forget what I'm looking for. Moles is going to be equal to molarity times volume. So here I've got 0.409 multiplied by, and again, the volume, I have to turn that into liters, so 0.05008. And if I work that out, I end up with 0.0205 moles of NaOH. Now, looking at this equation here, what is the mole ratio between the sodium hydroxide and the hydrochloric acid? And how you find that is by looking for the molar coefficients, right, which each of these being 1 here. I know the ratio of moles between NaOH and HCl is 1 to 1. So those of you who had me last year, sometimes you can do a dimensional analysis here if you want to just be sure, but you're literally just multiplying the number by 1. So I'm going to skip, and I'm going to right away know then that the moles of the sodium hydroxide is also going to be equal to the 0.0 0.250 because that mole ratio is 1:1. So I've now got the moles of the sodium hydroxide and I've got the volume. So now I can find my molarity of the NaOH solution. So it's going to be moles per liter. So it's going to be 0.0250 divided by the volume, which is 0.0350. And I get an answer of 0.586 molar. Now for this, I have to check my sig figs though. So I look back at all the information given to me here, 3, 4, 3. So it looks like my answer should have 3 sig figs, which it does. So we're all happy. Okay, so 0.586 is your answer here. Okay, so this one I would want you, if you're watching this at home, I would ask you to pause the video and see if you can do this one on your own. You're going to write your equation first, look at the information you have, use your mole ratio, and solve from there. So pause the video and then keep going once you get an answer here. Okay, so if I write the equation here, I've got barium hydroxide to start with. So barium hydroxide there, it's going to be aqueous. Plus, now this one I've got perchloric acid. So we have to write perchloric acid, which is HClO4, and that's also going to be aqueous here. It's going to break apart, and so these are going to reform a double displacement reaction. So I'm going to have my barium perchlorate, which is ClO4, and I need 2 of them, plus, and then it's going to be water. Now, I need to balance this equation, so I'm going to need a 2 here and a 2 here. Okay, now you're ready to go. So now we're going to write the information that we know underneath. Now, calculate the volume of, so I've got this molarity here, so 0.256 molar, and it's asking me to calculate the volume, so liters is my question mark. I have more information about the acid, so I know here I've got 0.0460 liters. I just went ahead and converted that into liters there. And I know my molarity is 0.407 molar. So, those M's. So looking at this, again, my question is asking me, or the question is asking me about the volume of the barium hydroxide, but I've got a volume, or sorry, I'm looking for volume, I've got molarity, but I'm gonna need moles to solve for this. Now, if I look at the perchloric acid, I've got a volume and I've got a molarity, so can I find moles by this, by those 2 pieces of information? Yes, I can. So I'm gonna go ahead and do that. So moles of the HClO4 is going to be equal to molarity times the volume. So I'm just going to multiply those 2 numbers together. So 407 multiplied by 0.0460. And you're going to get an answer of 0.0187 moles. Now, looking at that, that is your moles of your perchloric acid. Now, looking at the barium hydroxide, they are not going to have the same number of moles because the mole ratio is not 1:1, it's 1, this is a 1 here, remember, 1:2. So some of you would just quickly go through that multiplication there, or division I should say, but I'm going to use dimensional analysis just because I think a lot of you are used to doing that. So I'm going to say moles of barium hydroxide equals, and then I know the moles of the perchloric acid, I just calculated it, so 0.0187 moles of HClO4, and now moles of the perchloric acid goes on the bottom, moles of the barium hydroxide goes on the top, and then I need to look at the mole ratio between them, whoops. And the mole ratio between them is going to be 1 for the barium hydroxide, 2 for the perchloric acid. So 1/2. So I'm going to divide that number then by 2. and I get 0.00935 moles of barium hydroxide. So now my final step, because the question is asking me for the volume of the barium hydroxide. So again, molarity equals moles per liter. So if I want to solve for liters, it's going to be moles divided by molarity. So now I'm just going to plug in my data, 0.00935 moles. And the molarity of the barium hydroxide is 0.0256. Oh, did I throw in an extra zero there? I think I did. Oopsie. Sorry about that. Get rid of that zero. That's just a big decimal. It's a really big decimal. And you get an answer then when you work it out of 0.0365 liters. So that will be your volume. And again, you want to check your sig figs. So you go back to the question, 3, 3, 3. Yeah, I need 3 sig figs in my answer. So there you go. That would be your answer. So hopefully you were able to get that one on your own. Now, so for this assignment, you can now take a look at exercise 3. Okay. Oh, actually, I think I have. There you go. Exercise 3. You can check your answers on the key that's on the website, so I'll put the answers up for you. Check your work. Please make sure you're doing your assignments. It's really important to keep up here. Okay, thanks, everyone.